Okay, so I have a couple of consumer level printers. They're both inkjet printers. And I just thought I'd do a quick teardown on one so that I could illustrate some of the differences that I saw between this level of printer and the Pro Series laser printer that I tore down in my first video. I already took apart one of these printers. I had three that were generously donated for parts, and just like with the laser printer, you can get a lot of good parts out of something like this. Mostly it'll be stepper motors, springs, that kind of thing. Some of them have little LCD displays. If they're common enough, they're not too hard to reuse. But I took apart the cheapest of the three already, and I noticed that there was almost no metal in it whatsoever. It was almost purely plastic, except for the housing that actually held the print head going back and forth. So this was the next cheapest looking of the three, and they're all multifunction type. They all have the top scanner. The cheaper one actually had an auto document feeder, whereas this one just has a standalone scanner on the flatbed scanner on the top. So anyways, I'll take this apart and I'll just show you the difference in build quality between this consumer level stuff and something a little more on the towards the professional end. I'm not using my screw gun because this one happened to have there we go. This one surprisingly has torque screws instead of just standard Phillips. That's why I have my interesting little Allen key type multi-tool here instead of just the regular screw gun. That's also why this will take a little bit longer, just because I can't zip through it quite as fast. So I'm just got a couple of plastic pieces here, a little filter pad. Most all of the inkjet printers that I've taken apart have some type of reservoir at the bottom to catch extra ink, because they're not very efficient with the ink. At least compared to a laser printer that uses toner. Usually there's a screw underneath these rubber feet. And none of these consumer level printers came with a power supply inside of it. They all just have a plug on the back, and they use a power pack. Cheap Chinese stuff rather than having any integrated power supply circuitry. And I'm not going to be very gentle with this just because I don't expect to reuse it for anything. This is just for parts. So anything that has a flatbed scanner, you get a nice piece of document-sized glass out of it. The only thing that'll be a pain in the ass is there's usually glue or tape around here holding it in. In this case, you can see those little dots were just, looks like they were just dabs of hot glue. So have a nice relatively standard sized piece of glass if you're gonna make a project and you don't want a plexiglass window or anything like that. It's always nice to use a piece out of one of these. Just have a little holder, and I think this is just to seal the edge against light. That's a completely opaque piece of plastic. It's not a filter or anything. I'll finish tearing down the, oh, never mind. I was going to say I'll finish tearing down the main body first and then pull this apart, but once the glass came out, that just came off real quick. Even inside, I'm surprised that this has torque screws in it at all. The only piece of equipment that I actually had to break out my torque spits for before was a really nice, I guess you'd call it prosumer. It wasn't a big professional series copier, but it was definitely more than a little tabletop consumer level photocopier. It had a swivel base, and it had a couple of extra paper drawers, stuff like that, and that was torqued throughout. But this is the main button assembly for the top panel. You can see it's got power, stop, paper feed, and then just one little 7-segment, here, we'll get that focused, one little 7-segment LED. I'm assuming it's red. I never powered this thing on. Just so you can indicate the number of copies that you're making, and then a couple other buttons for scan or photo. And I've just taken the screws out, and the circuit board is just very, very simple. It's got a just a couple little an IC, a couple controllers for the LED, for the LED 7-segment display, one little status LED, and then a bunch of tack switches. I'll go through this a little later. The good thing, it's a single-sided board, so most everything on it, except for the ICs, is actually through-hole, but they're soldered on the top, so it'd be a little bit of a pain, but it still shouldn't be too bad to salvage some parts off of this. Just pretty much just the tack switches. The LED's a little surface mount device, that all, and then the 7-segment LED display. I'll take that just to play around with that. I might even leave it on the board. And then, of course, you've got a little clear acrylic button that went over the LED to show power, and then the rest of the buttons are just little injection molded things with a little dot on the back to press the tack switch, and then you've got a little light pipe to illuminate what was next to the buttons. So if you were gonna do, I'm assuming this is one side to the other, or feed a sheet, stop, whatever, it would just light up next to it to let you know what you've pressed. Not much point in saving any of that plastic stuff. And then the entire interface just had this little flat flex cable, and pretty much all of them seem to have just these little flat flex ferrites on them. I have a whole collection of these. They're nice to have around, just to keep with. I've got a separate bucket that I keep all this flat flex cable in, and I've got the flat flex ferrites next to them, because a lot of these, the LCD displays have a flat flex connector to usually to drive everything but the power to them, so it's really good to keep the flat flex cable with it, because you can always get a very fine an X-Acto knife or something, split the ends, the other end that went to the connector on the board, and then you can solder those to a Variboard or something like that, just to have easy access to the sending data and stuff to the display. And then this is the scanner assembly. This is actually cheaper than the scanner assembly on the cheap printer that I took apart before. I'll stick it in macro real close. It actually has the motor built into the scan head's just across here, and then all it did was drive this back and forth across a set of gears that was actually injection molded into the top of the case. The other one that I took apart at least had a gear system with a metal rod to keep it straight. This is just cheap plastic injection molded straight into the case, so I guess for what you're doing with it, it wouldn't be too bad. These are, I'm sure this is just another $50 throwaway printer. Anything that you get like this, the ink's going to be more expensive over the life of the printer than the cost of the printer itself. And you can see right here, all they did was take the flat flex and cut it down the here. Sorry, excuse the back and forth between the macro and the other mode, but they just took the flat flex and they cut it down the middle here to make two separate connectors on this end. One, I'm going to assume that this is for the, I won't assume, I'll look right here. This went in here, that was for the scanner head, and then these 1, 2, 3, 4, 6 leads went to the motor, so that's obviously power, speed control, and I'm sure there's a an opto interrupter somewhere in here to count revolutions or something like that, so it can at least get a rough idea of the location of the scanner head. So we've got that, and then this just one giant piece of injection molded plastic. Here's the I don't know if you can see, there we go. This is just the gears for the scanner head that was molded into place, and then the motor assembly and everything just slid in this little channel. Another little interesting thing, they actually just press fit the flatflex ferrite for the scanner feed straight into the a little piece in the case. And then this one actually has genuine HP cartridges still installed. The other one had the other one was a Lexmark. It just had generic Office Depot replacement heads, but you can see with these, and even with the genuine ones, there's still a bunch of ink that's left over on the print head after every print job. So just a little sticker on how to replace the heads. Little cheesy paper tray. Couple interesting looking bugs in there, but this is what I was mentioning before when I took off the underside of the case. These are just the pads to take care of the excess ink. So this is the flat flex that was for the control panel, and all it did was stick on the back of the control panel, go through the case, and down to the main board. And then this is the flat flex for the, you can see they actually had it manufactured with splitting it up in mind, because here's for the scanner head and here's for the motor control, speed control, and then they actually left a blank trace all the way, or a blank connector all the way through, and then when they cut it at the other end, you can see right here where they split it off just to make two little cables like that. And then the print head, of course, actually this is roughly the same as what I found when I finally got inside the other cheaper printer. It's all plastic, and then there's one basically stamped metal piece for rigidity, and you've got a I'm not sure what the official name of this thing is. I don't know if you can even, the camera will even focus on it so fine, but this is basically a ruler strip. It's got very, very fine lines on it, and there's an opto interrupter in the print head here. It went through, it's held across like this, and when the printer homes the print head, it knows where it is, and then the opto interrupter counts the lines on the piece of ruler plastic, so it knows exactly how far over it's gone. It knows when it's reached the other end, it can come back. So that's how, even in a very cheap plastic crap piece of kit like this, you can get the resolution needed to print text and decent quality images and make it look good enough to justify the purchase price. So this just, all it is you've got a motor. You've got a motor on this side, and then this is just a spring-loaded gear on this side that holds the drive belt, and the drive belt, the motor turns the drive belt, and the print head goes back and forth on this rod to lay down the ink. So, take this off. Inkjet Printers 101. And this is the cheapest of the cheap as far as printer technology like this goes. I'm not sure if there's anything else these days that matches it as far as cost versus quality, but this, all it has was a spring right here that goes on to this little wheel, and all that did was keep tension on the drive belt so that it didn't get loose. Stuff like this is really the best stuff that you're going to get out of a printer like this. I mean, if you really wanted to, you could, I'm sure you could reuse this assembly for something. I've yet to find a very compelling use for it. There's just a spring and a little clip on each end of the rod here. And springs like this, you never know that you needed them until some little cheap plastic crap that you have around the house breaks, and then you find out, oh, the pop-up lid to my trash can has a little spring that makes it pop up, and oh, somebody slammed the lid too hard, the spring fell off, or it fell in the trash can with everything else, and you're never going to find it. So come out to your box or bucket or whatever of springs, and if you take apart enough stuff like this, chances are 9 times out of 10 you're going to have one that'll fit, and you can replace it. You don't have to go out and pay another $10 for your plastic trash can just to get one replacement spring for the lid. So this is actually a nice, fairly beefy steel rod to guide the printhead assembly back and forth, and all sorts of applications for reusing this. Everything from a drumstick for my kids to you can cut pieces off and use them as hinge pins. I'm sure there's several other uses that people have for them. Pretty much a lot of this stuff, if you want to reuse it, you're only limited by your imagination. So it's got a little plastic housing to keep the ribbon cable in place, and then we've got all it is a little driver board to run the print heads. If you've never seen the control board, this is why the companies say you shouldn't use generic ink cartridges with their printers, because the cartridges actually have a little circuit board contact on the back of each ink cartridge, and the cartridge actually has the inkjet nozzles in the cartridge itself, and so all it does is get electrical impulses sent through the printer. When you snap in the print cartridges, they make contact with this back piece here, one for black, one for color, and these sell which jets to fire at which point to make your text or your image. So, and then just a little clip right here holds the entire thing at one point on the guide ribbon here, so that it doesn't move, or it doesn't slip when the motor's moving it back and forth. And interestingly enough, they have I don't know for what reason, but they stuck a little label over the chip here. I don't know if you can read the number on that. It's SC901930AH. Can't make out a date code on that, but then here, if you can see right there, that is the opto interrupter that read the little ruler strip to let the control board know where the printhead was. Okay, and if you can see right here, they do have a couple of little rubber pads that they come down out of the way when it's printing, and then it goes over, it lets whatever excess ink there is drip off into these pads. It comes back over here, and then these pop back up, and that just keeps the ink from drying out in between print jobs. And then we've got these little spring-loaded rollers here. Focus. Come on, focus. So these are actually nice little rollers and a fairly fat spring in there, and that's just to guide the paper. So nice little metal rods to use for, I don't know, you could use them for a punch or whatever. And then some nice, fairly beefy little springs for something like this. And this is pretty much the biggest piece of metal in the entire thing, except for the two rods. This rod just rotates to feed the paper through, and the other rod was just there for the printheads to glide back and forth on. And that plate actually isn't even as substantial as the one from the other printer. It's just a piece of pressed steel. Those things that fell off right there were just a couple more little felt pads for ink management. And actually, there's felt all over this thing. All these little pieces of felt, these are just for either for providing back pressure against the paper, or collecting excess ink as it's spewed everywhere. This is the motor that ran the printhead back and forth. It's just a little cheap Chinese single phase motor, and I'm sure it's not even going to be a stepper motor. It's just going to be a motor that was run with speed control coming from the main board based on the feedback from the opto interrupter that was on the printhead carriage. Another couple little springs. A couple little metal clips and stuff like that everywhere. This is the paper feed mechanism. It has another little motor right here. Again, not a stepper motor, just a little variable speed motor, a couple of gears, and then another little, in this case it's a ruler disc instead of a strip, and it just reads the position of the paper by this going through another opto interrupter that was right here. This one on the control board just fits through there, goes through there. It reads how fast the motor is going, and from there it just does a little quick calculation to infer where the paper is. Okay, so that's pretty much all she wrote for this thing, except for this little piece right here. I'm not going to be very gentle with it. This is just to feed the paper in from the back. Now, if you really want, you can, these little rollers are just on springs in here. You can take those out. But there's that. And this roller assembly, it uses this roller to suck the paper in. And then there's a couple opto interrupters on here. Take this circuit board out real quick. I'm not going to be gentle with the clips. All this board is, you've got an opto interrupter here, a couple of resistors, a little small capacitor, another opto interrupter here, and it just goes out to the main board. So here are just a few pictures that I took of the main board so that you can see it better. It's the whole board. This is the end with the main processor on it, and then here we have the other end that's just got USB controller power in. This is the main board from the lid that has all the control buttons on it for the scanner, copier, functions like that. The nifty little 7-segment display, which I'll reuse. This is the motor drive assembly for the scanner. Moves the scanner head back and forth across the page, and then this is the scanner interface board that takes all the data and sends it to the main board. These are the docks for the inkjet cartridges with all the control points, and this is the wheel that gives the main board feedback for how fast the paper is moving so that it can coordinate that with the movement of the inkjet cartridges. So I hope you enjoyed the teardown. Sorry it was so long in coming, but got a little busy and didn't have too much time to edit it and get it uploaded. So hopefully the next thing I'll get to is the main body of the Ricoh copier itself. And please subscribe, comment below, let me know if you like what I'm doing or you want to see something different, and I'll see you next time.